You have 30 seconds of oxygen left. The suit gauge is blinking red. Your hands are shaking. Outside the visor, the sky is not blue, it is a burnt, dead orange, like the inside of a furnace. The temperature is minus 70 degrees Celsius. There is no rescue team coming. There is no hospital. There is no air. You are on Mars. And you are already dying. 10. 9. 8. The ground beneath your boots is rust red and toxic. The dust in the air is not just dust, it is a chemical weapon, sitting in your lungs, slowly destroying the tissue. Your heart is beating twice as fast as it should. Your muscles, after 7 months in zero gravity, can barely hold your own weight. 5. 4. 3. And here's the thing nobody tells you before the launch. This is not the worst part. 2. 1. Most people, when they hear Mars mission, think of adventure. They think of Elon Musk standing in front of a rocket. They think of flags planted in red soil, of humans becoming a multiplanetary species, of history being made. They think it sounds hard, yes, but doable. After all, we went to the moon. How different can this be? Here's what most people miss. The moon is 3 days away. Mars, at its closest, is 7 months away, and that is only when the orbits align perfectly, which happens once every 2 years. In a car driving non-stop at 100 kilometers per hour, you would reach Mars in 60 years. It is not a road trip. It is not even a long flight. It is a journey into a place that does not want you there, a place that has been trying to kill everything on its surface for 4 billion years. And unlike the moon, unlike even deep space, Mars has an atmosphere. That sounds like good news. It is not. That thin, whispering layer of gas is one of the most dangerous things about the planet. Let me explain. Mars has an atmosphere. It is roughly 1% the thickness of Earth's. That means if you stepped outside without a suit, you would not just suffocate, you would effectively be standing in a near vacuum. Your blood would begin to boil within 15 seconds. Your lungs would collapse. Your eardrums would rupture. You would lose consciousness in about 12 seconds, and you would be dead in under 2 minutes. But here's the detail that makes this worse. That 1% of atmosphere. It is 95% carbon dioxide. The kind of gas that, in high concentrations, causes your body to go into respiratory crisis, rapid breathing, panic, loss of muscle control, cardiac arrest. There is virtually no oxygen. There is no nitrogen buffer. There is nothing that a human lung evolved to process. Now, a reasonable person might say, fine, we bring our own oxygen. We stay in the habitat. We only go outside in suits. And yes, that is the plan. But consider what that actually means. It means that for the entire duration of a Mars mission, which, because of the orbital windows, would last a minimum of 18 months, and more realistically 2 to 3 years, you cannot take a single breath of outside air. Every molecule of oxygen you breathe must be manufactured, recycled, or brought from Earth. Every system keeping you alive must work perfectly, every day, for years. There is no stepping outside for fresh air. There is no opening a window. There is no natural world to fall back on if the machines fail. The air on Mars will kill you instantly. The systems keeping you alive are one malfunction away from doing the same. Now look up. On Earth, we live under a global magnetic field and an ozone layer that together act as a planetary shield. They deflect and absorb the constant stream of high-energy radiation pouring out of the sun, solar flares, cosmic rays, charged particles moving at fractions of the speed of light. We don't think about this shield. We can't see it. But it is the reason life exists on this planet at all. Mars lost its magnetic field approximately 4 billion years ago. Its core cooled and solidified. And when that happened, the solar wind, a constant hurricane of charged particles from the sun, slowly stripped away most of the Martian atmosphere, and with it, all protection from radiation. On the surface of Mars, you would be exposed to radiation levels roughly 200 times higher than on Earth. Astronauts on the International Space Station, already far above our protective atmosphere, receive about 10 times the annual radiation dose of someone on the ground. Mars colonists would receive 20 times more than that. For context, the maximum lifetime radiation dose that NASA currently allows for astronauts is around 1 sievert. A Mars mission, with current technology, would expose a crew to roughly 1 sievert on the journey alone. Before they even land. What does radiation do to a human body? It breaks the DNA inside cells. Sometimes the cell repairs itself. Sometimes it doesn't. Sometimes it replicates the broken DNA, and that becomes cancer. Radiation dramatically increases the risk of lung cancer, leukemia, cataracts, and damage to the central nervous system. At very high doses, it causes radiation sickness, nausea, vomiting, hair loss, and eventually organ failure. There is no sunscreen for this. There is no pill. The only protection is mass, thick rock, thick water, or thick metal between you and the sky. Any habitat on Mars would need to be heavily shielded, ideally underground. And even then, during a solar flare event, which can increase radiation levels by a factor of 1,000 in a matter of hours, the crew would need to retreat to the most shielded area available and wait it out. On Mars, the sky is not your friend. The sky is trying to destroy your DNA. Now look down. The soil on Mars, what scientists call regolith, is not like Earth's soil. Earth's soil is a living ecosystem. It contains billions of microorganisms per gram. It is full of organic material broken down by plants, animals, fungi, and bacteria over millions of years. It is, quite literally, alive. Martian regolith is not alive. It has never been alive, as far as we know. It is, chemically speaking, a nightmare. Martian soil contains high concentrations of perchlorates, a family of salts that are deeply toxic to the human body. On Earth, perchlorates are considered hazardous industrial waste. They interfere with the thyroid gland, which regulates metabolism. They cause thyroid cancer. They are especially dangerous for children and pregnant women. In high enough doses, they are acutely toxic. The entire surface of Mars is covered in this stuff. Estimates suggest that Martian soil contains roughly 0.5% perchlorate by weight. That sounds small. It is not. If you tried to grow food in Martian soil, which is the only sustainable plan for a long-term colony, you would be growing that food in perchlorate-laced ground. Eating that food without extensive processing could slowly poison your thyroid. And no, washing the soil doesn't fully solve the problem. The perchlorates bind to the soil at a molecular level. I discussed the chemistry of perchlorate contamination in detail in a previous video on planetary habitability, but the short version is this: the ground on Mars is not just infertile. It is actively hostile to biology. It was not designed to support life. It was designed, if a lifeless planet can be said to be designed for anything, to destroy it. And the soil doesn't just poison you if you eat it. It poisons you if you breathe it. Mars has global dust storms. Not local storms. Not regional storms. Global storms. Storms that, once they start, can cover the entire planet in a thick, swirling haze of fine particles and can last for months. The Opportunity rover, a machine the size of a golf cart, built to last 90 days, survived 15 years on Mars. It was killed by a global dust storm in 2018. The storm blocked out the sunlight for so long that Opportunity's solar panels lost power completely, and the rover went silent forever. Now imagine you are a human being, not a rover, inside a habitat that depends on solar power. But the storms are not even the worst thing about Martian dust. The worst thing is that the dust is always there, even without a storm. It is electrostatically charged, meaning it clings to everything: suits, visors, solar panels, equipment seals. Over time, it works its way into mechanical joints, into air filtration systems, into the seals around airlock doors. It is finer than talcum powder. It is everywhere. And remember, that dust contains perchlorates. Every time an astronaut comes back from an EVA, an extravehicular activity, a walk on the surface, they bring dust back with them. Into the airlock. Potentially into the habitat. The dust will be on their suits, in their gloves, on the soles of their boots. Keeping it out entirely is, most engineers agree, essentially impossible. You can minimize it. You cannot eliminate it. Over a 2-year mission, Mars dust would be a constant, grinding, toxic presence. Literally in the air. Literally in your lungs. We haven't even landed yet. The journey to Mars takes 7 months in zero gravity. And zero gravity is one of the most destructive environments a human body can experience over long durations. In the absence of gravity, the human body begins to fall apart in very specific, well-documented ways. Bone density decreases at about 1 to 2% per month. By the time you arrive at Mars, you will have lost roughly 5 to 14% of your bone mass. Your skeleton, designed by millions of years of evolution to hold you upright under Earth's gravitational pull, has been partially dissolved. Your bones become brittle and prone to fracture. Muscle mass decreases even faster. Without the constant low-level work of simply standing and moving, muscles atrophy rapidly. Astronauts on the ISS exercise for about 2 hours every single day specifically to slow this process. On a transit ship to Mars, exercise facilities would be limited. Strength loss is inevitable. The cardiovascular system changes. Without gravity pooling blood in the lower body, the heart pumps against less resistance. Over time, it becomes less efficient. The heart actually shrinks. Blood volume decreases. When you arrive at Mars, where gravity is 38% of Earth's, your newly weakened cardiovascular system must suddenly work against gravity again. The adjustment is brutal. Eyesight deteriorates. Intracranial pressure increases in microgravity because fluid redistributes toward the head. This presses on the optic nerve, and over long missions, causes a condition called spaceflight-associated neuroocular syndrome, permanent visual impairment that, as of now, we do not fully understand and cannot reliably prevent. The immune system weakens. The gut microbiome, which regulates enormous parts of human health, is disrupted by microgravity, radiation, and stress. Latent viruses, herpes simplex, Epstein-Barr, varicella, reactivate in space at higher rates than on Earth. Your body, which has been fighting these viruses into dormancy your whole life, begins to lose that fight. You arrive at Mars weaker, sicker, and more fragile than when you left. And then the real challenges begin. I discussed the psychology of isolation in a previous video on extreme environment research, and I will not repeat all of it here. But consider this. The crew of a Mars mission would be, on average, roughly 225 million kilometers from Earth. At that distance, a radio message, traveling at the speed of light, takes between 3 and 22 minutes to arrive, depending on orbital positions. A conversation is impossible. You cannot call home. You cannot speak to your family in real time. You can send messages, and you can wait, for up to 44 minutes round trip, for a reply. This is not like being at sea, or in Antarctica, or even on the ISS, where you are hours or days from home, where emergency rescue is theoretically possible. On Mars, there is no rescue. If something goes wrong, if someone has a mental health crisis, if 2 crew members develop an irreconcilable conflict, if someone simply cannot cope, there is nowhere to go. There is no therapist's office, no walk in the park, no change of scenery. There is a metal box, and 4 to 6 other human beings who are dealing with exactly the same psychological pressure you are, and a sky full of poison and radiation, and a return window that is 18 months away. Mars analog studies, experiments on Earth that simulate Mars-like isolation, have documented increases in anxiety, depression, interpersonal conflict, sleep disruption, and cognitive decline. In a real mission, with real stakes, real danger, and real distance, these effects would be significantly amplified. The human mind was not built for this. Not because we are weak. Because we are human, social animals, built for sunlight, open space, and connection. Mars offers none of these things. To be fair, and this point is important, robotic exploration of Mars has been enormously valuable. It should continue. The rovers, the orbiters, the landers, they have told us more about the history of our solar system than almost any other scientific program. They have shown us evidence of ancient rivers and lakes. They have characterized the radiation environment. They have analyzed the soil. They have done this at a fraction of the cost, and at zero risk to human life. A robot does not need oxygen. A robot does not develop cancer from radiation. A robot does not lose muscle mass, or go mad with loneliness, or need to eat food grown in toxic soil. A robot can survive a dust storm by simply shutting down and waiting. If the goal is scientific knowledge, understanding Mars, understanding our solar system, understanding the origins of life, then robots are, by almost every measure, a superior tool. The argument for sending humans is not primarily scientific. It is emotional, philosophical, political. It is about what kind of species we want to be. That is a legitimate conversation. But it should be an honest one. Here is the synthesis. You have an atmosphere that will kill you in 90 seconds. You have radiation levels that will give you cancer. You have soil that is chemically toxic. You have dust that is everywhere and impossible to fully exclude. You have a journey that degrades every major system in your body before you arrive. You have a psychological environment that is among the most extreme ever endured by human beings. And you have a travel time that makes rescue impossible. None of these problems are unsolvable in principle. Shielding can be built. Habitats can be constructed underground. Suits can be improved. Radiation medicine is advancing. Psychological support protocols exist. Bone density treatments are being developed. Gene therapies for radiation resistance are being researched. But in principle is not the same as now. And, we could solve this eventually, is not the same as, we are ready to go. The people who will be sent to Mars, if we send them with current or near-current technology, will age faster than people on Earth. They will have significantly elevated cancer risk for the rest of their lives. They may lose their vision. They will be psychologically isolated in ways no human being has ever experienced. They will eat food grown in toxic ground, breathe air manufactured by machines, and live their days in a sealed metal structure while outside, the planet quietly tries to kill them. This is not alarmism. Every single thing in this video is peer-reviewed, published science. We love Mars because it looks like it might have been something once. Ancient river channels. The ghost of a magnetic field. A thin, ghostly atmosphere that whispers of a time when this place might have been warm, wet, and perhaps even alive. Mars is a tragedy. A world that had everything, and lost it, stripped bare by a dead core and a merciless sun over billions of years. And we look at this tragedy and see a destination. But here is the truth that no launch announcement will tell you. Mars is not a frontier waiting to be tamed. Mars is a graveyard with a sunset. The sunsets on Mars are real, and they are genuinely beautiful. Photographs from the rovers show a blue twilight as the thin atmosphere scatters light in the opposite way from Earth's. In photographs, it looks peaceful. It looks almost welcoming. It is not. What we see in those photographs is a dead world under an alien sky, radiating silence, saturated with poison, waiting patiently for whatever we send to break against its surface. Mars does not hate us. It is far worse than that. Mars is completely indifferent to whether we live or die. And that indifference, more than any storm, any radiation belt, any toxic dust, is what makes it the scariest planet in our solar system. If this made you think, share it. And if you want to go deeper into the science of why humans are so poorly adapted to space, the next video covers what zero gravity does to the human body in detail. Link is below.